So before anything else, let me introduce to the topical workbook for computer science 2210 or 0478. This is the workbook 1 for paper 1, basically computer systems. And as you can see from the table of contents, I've included questions on each and every subtopic from the syllabus along with the mark scheme. And these are some of the actual questions, actual pages as a preview from the workbook. Section 1.1, 1.3, 2.2, 3.2, 5.3 cybersecurity and artificial intelligence. This is just to show you a glimpse of what type of questions are included in the workbook. There are many more questions where these come from, and around 18 to 20 questions on an average are included for each and every topic. A must buy if you want to boost your grade. Similar to the paper 1 workbook, I have designed a paper workbook for paper 2 as well. This is for algorithm, programming and logic for CAIEs either 2210 or 0478 GCE or IGCSE Computer Science. As you can see, it contains questions on every subsection of the syllabus content for paper 2 along with the mark scheme, so you can understand each and every question, each and every algorithm. These are some of the few pages from the workbook just to give you a glimpse of what type of questions are included. As you can see, this is 7.1, this is 7.7, 8.3 and section 10 Boolean logic. So a lot more questions are included in the workbook. A must buy if you want to have a very good score in your Cambridge examination. Order now. Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another physics lecture, and continuing on with section number 1, motion, forces and energy. Today we are going to discuss section 1.7, energy, work and power. So energy is, in simple terms, the ability or capability of a body to do some work. Its SI unit is joule, that is having the symbol capital J. It is a scalar quantity, so it only has magnitude and not a direction. Now before anything else, you must remember the principle of conservation of energy, or the law of conservation of energy, that says that energy cannot be created nor can it be destroyed in any way. It can only be converted or changed from one form to another form. So we say that the total amount of energy of a closed system remains same or remains constant, but it can be transferred from one object to another, from one body to another. For example, a fan converts electrical energy or electricity into mechanical energy and thermal energy and provides air. Example number 2, burning of fuels or wood, which contains chemical energy in a stored form, releases light and heat. It can also be transferred from one body to another through work done or heat exchanges. Now there are various forms of energy, and energy can be stored as kinetic energy, the energy of motion, the energy possessed by a body due to its movement. Kinetic energy can be used to do work, and it can be calculated by a formula, and that is half mv square. Then we have potential energy, the stored energy inside an object. It can have the following forms. One is the chemical potential energy, or the chemical energy that is stored inside fuels, food or batteries. This energy is released through chemical processes. Example of chemical potential energy includes wood. When you burn it, you get heat and light, or batteries that give you electrical energy. Then we have elastic potential energy, the energy stored in a stretched rubber band or a stretched spring that is waiting, that would be released when you release the spring or the spring. Examples include a rubber band. When you stretch a rubber band, elastic potential energy is stored in the stretched rubber band, and when you release it, that energy makes it move and strike a target or just go leap in the air. Then we have gravitational potential energy, the energy or the amount of work done in order to raise a body to a height from a reference point. If you have to move a body to a certain height, then the energy that you apply to do that work is known as gravitational potential energy. Gravitational potential energy, or GPE, is always maximum at a high altitude, at a high point, and as a body starts coming down from the top, this energy is gradually converted into kinetic energy, and once the object hits the ground or is near the ground or near the bottom, at that time it has the lowest or almost zero gravitational potential energy, as all of it is gradually converted into kinetic energy. Then we have thermal energy, or this is also known as internal energy. It is the energy contained in an object due to its temperature. Then we have nuclear energy. The energy is stored inside the nucleus of an atom, and it can be released through fission or fusion through nuclear reactions. Then we have magnetic energy, the energy, the attractive or repulsive force that is observed when we are having two magnets together. The electrostatic energy, the energy produced by the attractive or repulsive forces of two charges. Energy can be transferred between objects, and this can happen through different processes. Examples include mechanical processes, when a force acts on a body. For example, collision of a moving car with one at rest makes it move too. Electrical processes, for example, transfer of energy from a battery to a bulb or fan or any other electrical component in a circuit in order to make that component perform some task. By heating, the transfer of heat from one object to another through conduction, convection, or radiation. These three are the methods of heat transfer, and you'll study about them in detail in section number 2, the thermal physics. Then the last, but we have radiation. Radiation is another way for transferring energy from one point to another, and radiation basically means using electromagnetic waves such as light or microwaves or even sound waves in order to carry and transfer energy from one point to another point. Example question: a pole vaulter runs along a track reaching a maximum speed of 8.4 meters per second. At the end of the track, he places a pole into the ground and uses the pole to push himself vertically upwards. If the mass of the pole vaulter is 60 kg, what is the kinetic energy as he runs along the track? And this time the examiner has asked you to clearly state the formula. Remember, even if the examiner has not mentioned this line, you have to mention the formula clearly in the very first line. So kinetic energy is supposed to be half mv square. So mass is given to us as 60 kg, and the speed is given to us, or the velocity is given to us as 8.4 meter per second. So 60 multiplied by 8.4 square, that gives us 2116.8, or almost equal to 2117 joules. You can write it as 2.11 kilojoules as well. The pole is used to convert all his kinetic energy into GPE, or potential energy, or gravitational potential energy. Calculate the height through which the pole vaulter rises. Give your answer to an appropriate number of significant figures. The gravitational field strength is 10 Newton per kg. Now remember the formula for GPE, or the potential energy, that is mgh. Over here we know that energy is always converted from one form to another, and we are given a hint that all the kinetic energy is converted into gravitational potential energy in the question. So we know that kinetic energy of the pole vaulter was 2117 joules. If all of that is converted into potential energy, that means the amount of potential energy is supposed to be also 2117 joules. Now plugging that into the formula, GPE equals to mgh. In place of potential energy we write 2117. For mass we know it is 60. G is given as 10, otherwise we would have taken it as 9.8, and the height we don't know and we'll need to calculate it. So we just simply rearrange the formula. H equals to potential energy divided by mass into gravity, and this would give us this value of height, that is 3.52 meters. Next we have work. Now when energy is transferred from one form to another form, or from one body to another body, we say that work has been done, or some work is done. It is a measure of the amount of energy that is transferred. Work is defined as a force applied on an object multiplied by the distance covered by that object in the given direction, or in the direction of the force. So simply, in order to calculate work done, we simply multiply the force into displacement. SI unit for work is joules, that is the same as energy. The formula for work done is same as the formula for torque, or the moment of forces. That was also force into distance, and the same goes for work. However, please remember one thing: in moment of forces or torque, we are talking about force and distance which are perpendicular to each other. Let me show you the slide. As you can see, the force and the distance are perpendicular to each other at a 90 degrees angle. Whereas when we are talking about a work done, then remember that when we are talking about work, the force and direction are parallel to each other, or the force being applied is in the same direction as the distance that has been covered. This is the major difference between work done and torque, although the formula looks the same. And SI unit for work is joules, that is denoted by J. It is the same as the unit for energy. 1 joule is defined as the work done when a force of 1 Newton is applied, or it makes an object move a distance of 1 meter, hence in the direction of the force. Hence 1 joule is also equal to 1 Newton meter. Newton meter is an alternative unit for measuring work done as well, but most commonly we take joule as the unit. Remember, whenever any work is done, energy is transferred from mechanically from one store or one object to another. The amount of energy transferred in joules is equal to the amount of work done, also in joules. So energy transferred is always equal to the work done. Now let's see an example question. Yeah, just remember one thing: the energy transferred is equal to the total work done. Sometimes while doing some work, some energy is wasted to the surrounding in form of heat or in form of sound or any other form, because we do not have any device or any system that can 100% convert one form of energy into another. Some of the energy is always wasted to the surrounding in form of heat, in form of radiation, in form of sound, in form of light, or any other form. But the energy transferred, the total amount of energy, means the amount of energy you try to transfer, is always equal to the work done plus the energy wasted to the surrounding, or the energy wasted during that transfer process. the total amount of energy always remains the same. Although we do not explicitly state that in the formula, remember that some little amount of energy is always wasted when we are trying to do a conversion. Example question. The figure shows a boat stationary in still water in a narrow tunnel. To move the boat, two men lie on top of it and push against the tunnel roof with their legs. They exert a total forward force of 1680 Newton on the boat. The men push the boat 50 meters to the end of the tunnel. Calculate the work done on the boat by the men. You know the formula for work done, force into distance, so simply plug in the values. Force is 1680 Newton, the distance is 50 meters, and the answer would be multiply these and you get 84,000 joules or 84 kilojoules, whichever unit you want to try. It's up to you. Explain why the kinetic energy of the boat at the end of tunnel is less than the work done on the boat by the men. Some work is done against friction, or some of the energy is utilized to overcome the friction or the viscous drag or the air resistance or whatever you want to call it. Or you can simply state that some of the energy is lost to surrounding or the environment in form of heat or thermal energy or internal energy to the surrounding.